Archiving started.
Hello, and welcome to the last recording session of this group focused on Introduction to Sampling. We have gone through looking at different types of sample, stratified random sampling, simple random sampling, so forth like this. We've looked at the descriptive statistics for samples drawn. And in the previous recording session, we looked at the sampling distributions associated with the sample mean. And these were probability distribution functions associated with different sample means that you could get from drawing samples of size n from an underlying distribution. In this session, we're going to turn our attention to sampling distribution of the sample variance. And again, the premise is that you have a probability distribution for a random variable, and you, as I mentioned in the previous one, imagine that you draw a sample from that of a certain size, and you, in this case, we're going to look and take the sample variance. We're going to calculate it for that particular sample. Tomorrow, we come back and draw another sample of the same size from that same population and calculate for that second sample the variance that we would have on that sample. Day 3, draw another sample from that population and calculate the values of for the variance on that sample. So you repeatedly draw samples, and from this you could then look and see what is the sampling distribution associated with the sample variances. Probability distribution function associated with the sample variance. So that would be the sampling distribution of S squared. If S squared is the variance of a random sample of size n taken from a normal distribution having a variance sigma squared, then the statistic is called a chi-square statistic, calculated as n minus 1 times S squared, the sample variance squared, divided by the population variance. This would have a chi-square distribution with n minus 1 degrees of freedom. These are just a couple of, or a number of different plots of different chi-squares. You notice the lower ones have 5 degrees of freedom on the lower left, and this would imply a sample size of 6, n minus 1, so 5 degrees of freedom. Or the one on the lower right is 10 degrees of freedom as an example, and so therefore a sample size of 11. So this is the distribution, this is how it would look, your distribution of the sample variance for different size samples that you would take. And they've been found to follow a chi-square distribution. Let's look at an example of this. Sampling distribution of S squared. A manufacturer of car batteries guarantees that his product will last on average 3 years with a standard deviation of 1 year. If 5 batteries have lifetimes of 1.9, 2.4, 3.0, 3.5, and 4.2 years, is the manufacturer still convinced that his batteries have a standard deviation of 1 year? Assume that battery lifetime follows a normal distribution. So we first find the sample variance associated with this these five different batteries, and we use the formula provided in previous recording sessions and in your textbook for finding that sample variance. Turns out it is 0.815. Next, we calculate our chi-square statistic. And again, that was number of degrees of freedom minus 1 times the sample variance divided by the population variance. So n minus 1, in this case, is 4. Sample variance turned out to be 0.815. And the conjectured standard deviation and variance for the full population is 1. So the chi-square statistic turns out to be 3.26 with 4 degrees of freedom. And then if you look in one of the tables for chi-square, you would find that 95% of chi-square values with 4 degrees of freedom fall between 0.84 and 11.2. 1, 4, 3. Fairly wide interval there. And so the computed value with the assumption that the population variance is 1 is therefore reasonable because the 3.26 falls within this interval. So that's just one example. If you go to the Blackboard, I've given you a number of other example textbook exercises. Again, as with all these recording sessions, this is the first brush on the topic and first kind of glance at what it is. I refer you back to your textbook to do additional reading on it. And then when we are in class together, we will go through some additional exercises to get you familiar with not only the sampling distribution for sample variances, but also for the sample means. This concludes this group of recording sessions for the introduction to sampling, and we'll see you at the next round.